right, let's go and get started and take your homework out if you would. Books open to page 19. I trust you spent some time studying over section 1.1 last night. Trust you looked over the different laws of exponents and order of operations and negative exponent stuff and all those different ways we can translate algebra, or words rather, into algebra. Numbers 1 through 8 from your homework were some more review from that first section of your textbook. So some good review for the quiz. So we're going to go over just the first 8 homework problems, then we're going to take the quiz, then we're going to come back and finish the homework, which the last 4 problems from the homework are not going to be on the quiz. All right, so number 1, we are writing without denominator. So if it's in the denominator, it's got to move up. And number 1, Audrey, what did you have? Good. X cubed z to the negative second. She was thinking about it. I said negative squared, negative 2, negative second. Good job. Good guess. Number 2, Genesis. Well, it is a w squared in the bottom, but when it moves up, moving it up is taking a reciprocal. And to show I took a reciprocal, I've got to use what kind of exponent? Negative exponent. So it should be rw to the negative second, the one that Audrey just said. All right, number 3, Brandon.
C squared, k to the 4th, v squared, and then y to the negative 4th.
Good. The c squared, k to the 4th are fine. We're going to move it up as a v squared, and then move up as a y to the negative 4th. Number 4, Michael.
H, p to the 7th, q to the negative 2nd, w to the negative 4th.
Excellent job. The only hard part here was that h. You're moving the h squared up as an h to the negative 2nd. Add those exponents, or just think practically, 3 h's in the top, 2 in the bottom. Cancel away 2 of them. All you're left with is the single h in the top. So a couple ways to approach that. Notice we didn't need to move the q down, so it stays a q to the negative 2nd. Good job. H, p to the 7th, q to the negative 2nd, w to the negative 4th. Number 5, Noah.
G squared, n, v to the negative 3rd, and y to the negative 2nd.
Well, if you look at the problem in your textbook, number 5, the y already has an exponent of negative 2. So it already is a negative exponent. So when you take the reciprocal, Noah, by moving it up, you're going to make it the negative of a negative, which makes it a positive, right? So since it was a negative exponent, as it moves up, it becomes positive, hence y to the 2nd, or y squared. So g squared n, v to the negative 3rd, y squared. Should have been our answer for 5. Kendall, number 6.
H cubed, r to the 4th, k to the 4th.
Yeah, we've got a little out of alphabetical order there, so we do h cubed, then the k to the 4th, then the r to the 4th, but it is a correct answer, just minus a point. Good. Anyone get all 6 of those correct? Anyone 6 for 6? How about 5 for 6? Just missed 1. All right, the one that we missed, do we understand? All right, number 7. They wanted us, first of all, to write the algebraic expression 3 less than twice x. Maddie, how would I write that? All right, 2x minus 3. And then it said evaluate it, or find the value if x equals 4, and you got, of course, 5 for your answer. Following order of operations, we multiply, get 8, and then subtract the 3. Number 8, we need 12 more than half of y. How would I write that?
1/2 y plus 12.
Good. Half of y plus 12, or better yet, half of y means you could divide the y by 2 plus 12. And now instead of thinking of multiplying by half, dividing by 2 is easier. Either of these would be acceptable. And then it says if y is negative 6, what do we get when we evaluate?
9.
9 as our answer. How many got 7 and 8 both correct? 7 and 8 both correct. Noah, any questions? You're good to go now? Any questions at all in section 1.1? Exponents, order of operations, translation of algebra, any of that? All right, Gavin and Brecken, if you have any questions, be sure to let me know before you take the quiz. The rest of you, go ahead and clear your desk, except for a sheet of paper and a pencil. One clean sheet of paper and a pencil, everything else away. Make sure your notes are closed and beneath your desks. Aerodynamics going on. Sheet of paper, pencil, everything else away. First and last name at the top of your paper. A standard heading, so your first and last name at the top left corner, top right corner, on that top, well, the first line, I guess, not all the way up in the corner, but on that first line, today's date, And somehow we don't have a calendar in here, but I think it is August 17th, 8/17/21, today's date. And for the assignment, just put quiz 1. The assignment there in the middle of that second line, just put quiz 1. All right, you're going to use the quiz copy as a cover sheet. Use this to cover your work. Do not write on my quiz copy. Well, Brecken and Gavin, y'all can write on the quiz if you want, because I'm not getting it back. Anyway, you guys in here, do not write on the quiz copy. Write everything on your own paper. Let's take a look at the quiz together very quickly. If Brandon will hand those other quizzes back. There we are. Excellent. There we go. Okay. Numbers 1 and 2, solving using order of operations. Be sure to show your work so you can get partial credit, just in case you manage to mess something up. Numbers 3 through 6, translate those words into algebra. Think carefully through those. Numbers 7 and 8, I just want you to describe which algebraic property is being used. We talked about 5 different properties. Which one is being illustrated? And then for numbers 9 through 12, simplify the expressions. I don't want negative exponents in your answers. All right, using the quiz copy as a cover sheet, you may begin. You make sure you are using that quiz copy as a cover sheet to keep your answers covered as best you can. When you finish, just turn your paper over and sit quietly. About 2 more minutes to be finishing up. 2 more minutes to finish. Just 1 more minute now to finish. I give you 2 extra seconds. All right. So I guess technically, Scott, or Gavin, and Brecca, you could always pause the video and give yourself more time. I will never know. The rest of you, page 19 in your textbooks. Let's finish looking at the homework that you did last night. And we were practicing yesterday with adding and subtracting and multiplying polynomials. And we said, if we want to add polynomials, we need to remember that you can actually only combine terms class that are like to each other or similar to each other. What does that mean for terms to be like to each other, Abby?
Have the same letters.
Could have exactly the same letters. And again, to be clear, if I have like a 5x squared y cubed, you might say, well, what are the letters? And some people might say, well, x and y. No, x, x, y, y, y. We just don't write it that way, right? So if I said 7xy, is that a like term? Well, no, this only has an x and a y. This has 2 x's and 3 y's. These are not like terms to each other. But like terms, of course, can be combined. And as we add them, of course, we just follow our addition rules, right? If signs are the same, add and keep the sign. If signs are different, subtract, keep the sign of the greater absolute value. So doing what we know to do with signed numbers from our years of practice with that. Subtracting polynomials. We said, well, really, Genesis, we don't really subtract. What do? We really add the inverse. So when we see a subtraction sign, anything that's grouped after the subtraction sign, you're going to change its sign. So that which was positive becomes negative, that which was negative becomes positive. And we go right back to our addition rules once again. And then for multiplication, we only made it as far as monomials. Sometimes just like a number, like 3 could be considered a monomial. Sometimes it's like a 3x squared y cubed. And multiplying it by a polynomial. And we said we call that what, Maddie? We multiply a monomial by a polynomial. Kendall? Anyone? Distribution. Distribution, when you multiply a monomial times a polynomial. And I used the example when I was teaching this in Algebra 1. Some of you might remember if I had a bag of candy and I was just like, you know what, I feel like giving candy to people. So I give some candy to Brandon and candy to Genesis and candy to Audrey and Noah and Michael and Maddie and Abby. Where did I get Aubrey from? Abby. I've distributed candy to the class, right, Kendall? No, because I didn't give Kendall any candy. I can't give candy to Brecken and Gavin, sorry. But to distribute to the class means everybody gets some, right? So when we multiply, everything must be multiplied by that monomial that's getting distributed. That's what we were practicing in 9 through 12. Let's take a look at number 9. Adding like terms together, and not everything has a like term. What did you get for your answer on number 9? Abby?
G cubed plus 2g squared plus 5g plus 14.
Very good. G cubed plus 2g squared plus 5g plus 14. Number 10, once again, we don't have all like terms, but our bigger issue is it says to subtract. So the first thing we have to do, class, is add the inverse. Change all of those signs so that we can add. And here I go calling her Aubrey. Now I'm about to call you. I don't even have an Aubrey. Audrey, what did you get on number 10?
3x to the 4th minus x cubed minus 23x minus 9.
Good. 3x to the 4th, negative x cubed, negative 23x, negative 9. Number 11, we've got to first distribute, then combine terms. So let's take this piece at a time. Genesis, what do we get when we distribute the 2?
2w squared plus 6w plus 24.
Good. 2w squared, positive 6w, positive 24. Then we also distribute the negative 4 to get?
Negative 4w squared plus, or minus w plus 24.
Minus 4w, and then the plus 24 at the end. Negative 4w squared, negative 4w, positive 24. We combine everything together, and we didn't get it, or?
I had mine.
Okay.
I was just looking at my book. So
Okay, you were trying to do it in your head instead of reading off your work. What was your answer for number 11, Genesis?
Negative 8w squared plus 2w plus 48.
Okay, see what you did. You did a good job combining the w's to get the 2w. You had your 6w and your negative 4w. Good job combining the 24s to get 48. You saw your 2w squared and your negative 4w squared later, and instead of combining them, you multiplied to get negative 8. But really, it's a positive 2 and a negative 4, and when we add those together, we just get,
8.
we're adding them together. So,
6.
all right, so I give you $2, and then I steal $4. What's actually happened here? Negative how many, though? If I give you $2, I'm like, you know what? No. I'm going to take $4 from you. You come out on the short end, right? How much do you come out on the short end there? $2, right? Negative 2w squared. Remember, signs are different. Subtract the numbers, 4 minus 2, 2. Keep the sign of the greater absolute value, and of course, keep the w squared. So this should have been our answer there. Number 12. What did you get on your initial distribution, Brandon?
So the answer?
Not the answer. The initial distribution, distributing the 6 first.
So I got 6y cubed, negative 6y plus 66 plus
Okay, and then you distribute the 3.
3y squared minus, negative 21y plus 6.
There we go. Now, that middle term should have been a negative 12y. On that first distribution, the 6 times the negative 2y. So that's going to mess up your answer. Let's see. Michael, did you have the distribution correct?
Yes.
What did you get for your answer?
6y cubed, that's a plus 3y squared minus 9x plus 72.
Had a little trouble there with it. So that's actually a y, but you had a negative 12y, and you should have also had a negative 21y. Oh, that's what happened. Negative 12y, negative 21y. Careful, you don't subtract these from each other, they're both negative. And when the signs are the same, we add and keep the sign. Should have had
33.
and keep the sign.
Negative 33y.
Negative 33y. So the answer should have been 6y cubed, positive 3y squared, negative 33y, positive 72 for our answer. And I didn't get all 4 of those right. You got all 4 right. Okay, a few of you did. Questions on any of them? I took a look at a few. Are there questions or we still need to see something worked out? Going once on questions, twice on questions. Gone on questions. Next section in your notes. Next section in your notes. Worked on distribution yesterday, worked a little bit on distribution even today. Remember, distribution is multiplication. And when you multiply like bases, class, you add the exponents. Here we want to move on now to multiplying, instead of a polynomial by a monomial, multiplying a polynomial by another polynomial. Next section in your notes, multiplying a polynomial by yet another polynomial. I refer to this process as double distribution. And I think if we think of it in these terms, it'll make it easier for us. Double distribution. So long as we've got the concept of distribution down, that is, you multiply by everything, even Kendall, no matter how small the term, you still have to give that monomial, multiply it by that other term in the parentheses. But I do put a little asterisk here with the double distribution, because this is the most common form of polynomial by polynomial, but you realize we could do triple distribution, quadruple distribution. I mean, if you put me in a really bad mood, quintuple distribution. I mean, be nice to the 2 math teacher. He can make your life miserable. I can cause all kinds of problems. Okay, anyway. Okay, so the first time I ever heard that joke wasn't even intentional. Juniors, seniors that are in here, you're going to be doing a vocation project this year in English class. And your vocation project basically is you think, okay, this is what I think God wants me to do with my life. I don't know. Maybe you do know, but maybe you don't know, but you're like, I think this is it. And you're going to do a report on what it takes to become that. And by the time you're done, one of 2 things will happen. You'll either be really excited about doing that thing, or you're going to never want to do that again in your life. You'll be like, no. After writing a report about that, I'm done with that idea. Either way, it's a win, because either you saved a year of college by deciding not to try that, or you're really excited about it, and now you're ready to go. So I did mine on becoming a math teacher, because my senior year, I was like, I want to become a math teacher. So part of the process you're going to have to do is you're going to fill out a question, or you're going to send questionnaires to people that are actually doing what you want to do one day. And one of the, it's a form questionnaire, you're going to be told what to put on it, is what kind of problems does a blank face? What sort of problems might a blank, construction worker, lawyer, doctor, whatever face? And of course mine says, what kind of problems might a math teacher face? I didn't think anything of it. And one of the math teachers that returned it to me, that's really funny. I didn't even recognize the joke now, I feel bad. But I've been using it ever since senior year. Anyway, how do we get off on that? Anyway, double distribution. Page 11 in your textbooks. A little rabbit just hopped away. What he's doing over there. Page 11. Look at the example at the bottom, and we're going to do things just a little bit differently than the book does, okay? And those who've had me before know I a lot of times do things different from the book, because I like to do things the easy way, because I am lazy. Okay, so here's the problem in the book. I want you to copy it on your paper, because like I say, we're going to do it just a little different. It's the same basic idea. It's not like we're like, well, we don't multiply like this. When we multiply 2 times 5 is 7. We're not doing anything that radical or anything. Just the way I approach the problem. Because if we had a monomial right here, I would just distribute 1, 2, 3 times, right? Well, I'm going to have a monomial right here. I'm going to ignore the existence of the plus 3. Do any of you ever feel like a plus 3? People just ignore your existence. Mm-hmm. Yeah. You never feel ignored, do you, Kendall? I don't ignore you, do I? Anyway, you can stand for a little ignoring sometimes. Anyway, but we're going to ignore the existence of the plus 3, and we're going to distribute the 2x as if that's all that exists. So the plus 3 in your mind is not there. We're just distributing the 2x. Sign, number, letter, class. When we distribute here, we get 2x cubed. Now distribute to the negative 6x. Sign, number, letter?
Negative 12x squared.
Negative 12x squared. Again, ignore the 3. 2x times negative 2. Sign, number, letter? Negative 4x. That's all we've done so far. That's an ordinary distribution, right? Something we've already been doing, we're good. Now I'm going to ignore the existence of the 2x. And I'm going to distribute the 3, the positive 3, all the way through. Hence double distribution. I'm distributing twice. When I distribute, though, I'm going to try to place my answers lined up nice and neatly with these terms if I get a like term. So for instance, when we distribute here sign, number, letter, class, we get 3x squared. I'm going to put that right below the negative 12x squared. When I distribute the 3 times the negative 6x class, negative 18x. When I distribute the 3 times the negative 2, negative 6. Again, it's easy multiplication. It's sign, number, letter. But by doing a double distribution, it just clears the error a little, makes it easier for me to focus. But if you line up like terms, you literally have your partial products all ready to add. And so now we add 2x cubed plus nothing. Negative 12x squared, positive 3x squared. Careful, signs are different. Negative 9x squared. Signs are the same here. Negative 4x, negative 18x. And negative 6 has no friends. And there we go. Easy enough. Now, one of the reasons this worked so well was that I could really kind of just write the terms in order, couldn't I? Will that always happen? No, not always, right? The like terms don't always line up so neatly. But if you have like terms, line them up. One of the reasons it worked, though, is notice the order here, right? Squared, first, 0 power, first power, 0 power. The powers keep getting smaller in each grouping. We call this class descending order. Good. If you have descending order, it will oftentimes make things work really nicely. Questions on the double distribution. Look, if you would, at the top of page 12. And here we have not a double distribution, but a triple distribution. And it's just the way it goes in life. There's 3 things to distribute, but that's okay. You still follow the process through. We're going to start by only focusing on the x squared. Ignore the existence of everything else and just distribute to the other polynomial. So again, this doesn't exist. You only think it does. It's all in your mind. The x squared is going to get distributed. Sign, number, letter, class. Sign, number, letter. There we go. And sign, number, letter. Notice, by the way, they were all in descending order, so this is going to work out nicely. Now, I'm only focused on the 7x. Distribute sign, number, letter. And that goes right under the other x cubed, sign, number, letter. Negative 28x squared. All right, and then the last sign, number, letter with the 7x. Third distribution. This guy. This doesn't exist forward, just this, sign, number, letter. Notice that's going to line up with the other x squares. Sign, number, letter. Positive 8x. And sign, number, letter. Who again has no friends. You ever feel like a negative? Anyway, all right, so let's take a look. Brandon's like, he's picking on me. I'm sorry. All right, so let's... At least I got your name right today. I told Dylan I kept calling you by his name. He thought that was funny. He's a jerk, isn't he? All right, let's go into our first column here. X to the 4th plus nothing and nothing class. X to the 4th. Negative 4x cubed, positive 7x cubed signs are different. Positive 3x cubed, subtracting the sign of the greater. Now here we've got 3 numbers. Combine the 2 negatives first to get negative 30, because the signs are the same, add and keep the sign. And then combine that with the alternate sign by subtracting, keeping the sign of the greater. Here, signs are the same. Positive 29x, and negative 6 again has no friends, as we said, so negative 6. And there's our answer. Methodical, process-based, but not hard. Does it take a little while? Yeah, though it would have gone faster if I hadn't talked so much. But, point is, it wasn't the end of the world. Questions on the best way, in my opinion, to set this up. Now, could you have absolutely no like terms? Sure, if you had like x plus y minus 2, and you distributed like an a plus 5. Well, let's go ahead and do this double distribution very quickly, and we'll see nothing lines up. So we start by distributing class just the a. Ignore the existence of the 5. So we distribute the a to each of these, and we get first class ax plus ay minus 2a. Everybody gets an a. Remember, numbers go before letters. All right, then we ignore the existence of the a, and we distribute the 5 to get 5x, but that's not like to any of these, so it gets its own column. Then we get 5y, that's also not like to any of these. And then we distribute to get negative 10, which is also not a like term to anything, and nothing combines. Right? So that can happen sometimes where it doesn't combine with anything. That's okay. If, though, you get like terms, lining them up in nice, neat columns should help. Questions on this? Only once on question. Twice on question. Gone on questions. Turn to page 15. Page 15. Quince. Do numeros, I don't know how to say 22, 26, and 28 in Spanish, so we'll just say it in English. Page 15. Number 22, 26, 28. Working those 3 at your seats. That now is finished. You have to do 3 distributions on 28. You only did 2. That's why. So it actually may not be, the first 2 things might not be wrong. It is the precedence on the answer, but you may just need a 3rd distribution to go through. Several people finishing up here. Take another 30 seconds to a minute to finish up if you're not done yet. Then we'll go over all 3 answers together. take a look at these together. Number 22, check your distributions. Your first partial product should have been a negative x cubed, negative 8x squared, positive 8x. Then down below that, you should have had the partial product, positive 7x squared, positive 56x, negative 56. Combine all of that together to get negative x cubed, negative x squared, positive 64x, negative 56. How many had the correct answer on 22? All right, so just a couple of you did not. Did you find your mistake as I went through it? Those who missed 22, did you figure out what you did wrong? Or do we need to see it on the board? Got it right, okay? Figured it out? Okay. All right, number 26, check your first partial product, negative 9x cubed, positive 18x squared, negative 12x. Your second partial product, 21x squared, that's a positive, negative 42x, positive 28. You combine them all together, here's your answer, negative 9x cubed, positive 39x squared, negative 54x, positive 28. How many had that answer for 26? All right, so just a couple of you missed that one. Okay, questions from those who missed it. Did you find your mistake as I went through it? Genesis, did you find your mistake? You did?
Yes.
Okay, all right. I was looking for some kind of indication. Again, I don't mind working on the board. That might even help Gavin and Brecken. Sorry, Brecken. Gavin and Brecken if we go over it. So, but nobody needs to see it on the board. All right, sorry guys. All right, number 28, triple distribution. 3 partial products here. First partial product, 3r to the 4th, negative 20 or negative 9 r cubed, positive 12r squared. Next partial product, negative 15r cubed, positive 45r squared, negative 60r. Final partial product, positive 6r squared, negative 18r, positive 24. Add them all together, your final answer. 3r to the 4th, negative 24r cubed, positive 63r squared, negative 78r, positive 24. How many got the last answer correct? 28, those who made it that far. All right, those who did not, did you find your mistake already, or do we need to go over it? Did you find your mistakes? You did not, so we need to go over it. Let's take a look at this one together. Right after we make that thing be quiet. All right, so r squared, negative 5r, positive 2. And 3r squared, negative 9r, positive 12. Probably going to look at one of these anyway. By the way, those of you who were in Algebra 1 last year might be like, I want to take out a 3. We're not factoring right now, we're multiplying. So we're going to start with the r squared, distributing all the way through. Again, sign number letter gives us a 3r to the 4th. Wouldn't hurt to put the positive. Not necessary, though. Here's sign number letter. There's our negative 9r cubed. And then here's our positive 12r squared. Those who missed this one, so far, so good? Okay. Then distributing the negative 5r to get negative 15r cubed, which we'll put right down here. Then here's a positive 45r squared, which also lines up nicely. And then a negative 60r. Still so far so good, or did we hit the mistake? We found the mistake? Still good? All right, words help. Like, what does that nod mean? All right, and then the positive 2. 6r squared is going to go right down here. Negative 18r and positive 24. Still good? So the partial products were not the problem. Maybe it was combining of like terms. All right, so here we've got our 3r to the 4th. Here signs are the same. Add and keep the sign. Negative 24r cubed. Signs are all the same. Just add it all together. Let's see, it's 13 is a 63. R squared. Here signs are the same. This is great. They're all signs the same. Negative 78r, and then, of course, the 24 who has no friends. So we figured out what we did? All right, questions on this. Questions on this. Take a look at number 20, and do numbers 20 and 24 at your seats. The goal, all of you, perfect on both. So we got all our mistakes out of the way on the last round. No mistakes this time. Pay very careful attention to every sign, every number, every letter, even more than you're trying to go fast. Every sign, every number, every letter, every X, going to get it all perfect. Because if it's not perfect, this could be you. was done fast. Several people finishing up. Take just about 30 seconds longer. All right, let's take a look. Abby, number 20, what was your answer?
X cubed minus x, negative x squared, negative 3x, positive 18.
So close. What's 3 times 9, Abby?
27.
27. Doesn't it stink to be human sometimes? All right, so modified answer, x cubed, negative x squared, negative 3x, positive 27. How many got that correct? Everybody but Abby. All right, Abby wants redemption. All right, number 24, Abby, what did you get for your answer?
2x cubed, negative 15x squared, negative 9x, positive 8.
There we go, 2x cubed, negative 15x squared, negative 9x, positive 8, redemption for Abby. How many, like Abby, got number 24 correct? Abby's brother. All right. All right, what was your answer for 24, Michael?
Instead of a negative 9x, I got a negative 2x.
Negative 2x. All right, let's take a look here. So you would have had a negative 16x at the end of the first partial product and a positive 7x.
I got 14x, so that's where I
I should have had a negative 14x squared the term before that, right? But yeah, then the positive 7x should have happened there. So careful with that. So the strategy tip, what you could do is take your pencil and, for instance, you got the 2x minus 1 as the lead polynomial. Maybe you do lightly scratch this out with the pencil, do the distribution, take your eraser. Of course, your eraser wouldn't erase the printing in the book, but erase this to the negative 1 is visible, and now scribble this out, maybe just to help you focus, because it looks like you just brought the 2x and started incorporating that. So, I don't know, maybe a strategy tip there to keep you from getting them mixed up. But that means that 6 of you got all of them perfect, and maybe 8 of us, depending on how Brecken and Gavin did. Questions on the double distribution? All right, short homework assignment this evening, page 15. Page 15. You'll do numbers 19 to 27, the odd. Page 15, numbers 19 through 27, the odd. We'll take a look at that tomorrow, and then I'll start teaching you, reviewing with you technically, shortcuts of multiplication, ways in which we can multiply very quickly in our head with very little work. You do have just a few minutes if you want to go get started on that, and then when the bell rings, you'll be dismissed. Have a wonderful rest of your day.